Unit 10, Day 6 Notes. Today we're going to talk about special segments in circles. Chord segments. Chord segments are segments that form when two chords intersect inside a circle. So looking at my circle on the right, the two chord segments would be segment AC and segment ED. They are chord segments and, I'm sorry, rewind. Let me erase. There are four chord segments on my example on the right. AB is one, BC is another, EB is one, and the last one is BD. Those are the chord segments because they're formed by taking chord AC and chord ED and who meet at point B. So the first four I mentioned are your chord segments. Theorem 1015 says, if two chords intersect in a circle, then the products of the lengths of the chord segments of the chords are equal. So using the same illustration from above, this theorem is saying that the product of AB times BC is equal to the product of EB times DB. So essentially it's part times part equals part times part. A secant segment is a segment of a secant line that has exactly one endpoint on the circle. An external secant segment is a secant segment that lies in the exterior of a circle. So on our figure on the right, AC and AB and AE, that's an E, sorry, and AD are considered secant segments. And then an example of an external secant segment would be AB and AD. Theorem 1016 says if two secant segments intersect outside a circle, then the product of the measures of one secant segment and its external secant segment is equal to the product of the measures of the other secant segment and its external secant segment. So what this is saying is this part AB times the whole thing AC is equal to the other part AD times the other whole, which is AE. A tangent segment is a segment of a tangent with one endpoint on the circle. And we mentioned this a couple days prior, but this is just to remind you of the definition of a tangent segment. So on the illustration at the right, JK would be a tangent segment. On theorem 1017, it says if a tangent segment and a secant segment intersect outside the circle, then the square of the measure of the tangent segment is equal to the product of the measures of the secant segment and its external secant segment. So what this is saying is, using the same picture, the square of JK's measurement is equal to the product of the secant segment, which is JL, or JM, sorry, times JL. So part times whole. So this sums up some of the theorems. Hopefully it simplifies some of the ideas for you. So if you have two chords intersecting inside the circle, then it's part times part. So part times part equal to part times part. So part times part. So in other words, since there's actual numbers, let's use them. It would be x times 8 equal to 6 times 5. And then you continue to solve the problem as it is requested. But I'm just helping you to set it up at this point in time. If it's two secants, then it is outside, which is, this is the outside, and then this is the whole. And then again, outside, and this is the whole. So outside, which is 13 times the whole, x plus 13 is equal to outside, which is 9 times the whole, which is 9 plus 30, or 39. So we're going to practice using all of these theorems, so don't worry. And then on the last case, you have a secant and a tangent. And the whole, outside times the whole, will equal the tangent squared. So in other words, 4 times the whole thing, which is 9, is equal to x squared. Okay, so hopefully this sums it up just a little bit and makes it clear for you. So example 1, we're going to find x. JL is a chord. PM is also a chord. So we have two chords intersecting inside the circle. So this is a case of part times part equals part times part. In other words, JK times KL equals PK times KM. So JK is x plus 10. KL is x. PK is x plus 1. And KM is x plus 8. So now we have to multiply The left side is a little easier because all you need to do is just distribute this x within the parentheses. When you distribute, you're going to have x squared plus 10x. On the right side, we would need to do the 2 by 2 box, or the FOIL method, if you remember the FOIL method. So the labels of the box would be x plus 1, and the side would be x plus 8. All right, so x times x is x squared. X times 1 is 1x. X times 8 is 8x. And 8 times 1 is 8. So the results of multiplying those two binomials is x squared plus 9x plus 8. So now you got to combine like terms. The first thing I would do is subtract my x squareds. In doing so, they cancel each other out. So bring down what is left over, which would be 10x equals 9x plus 8. And now subtract 9x from both sides. It cancels on the right, but on the left, you're left with x, and it's equal to 8. And I'm done. All it asked for me to do was find x. Number 2, I have two secants, G, J, and LJ. They're two secants. So when it was two secants, it was outside times whole equals outside times whole. So in other words, JH times GJ is equal to KJ times LJ, which is the whole. So again, outside, outside, whole, and whole. All right, so that would be 8 times x plus 8 for the whole thing, since one part is x, the other part is 8. KJ is 6 times the whole thing, which is 16, because 10 plus 6 is 16. So now you have to distribute the 8 into the parentheses, giving you 8x plus 64, and then multiply 16 and 6, and you get 96. Let me double check real quick, because I'd hate for this information to be wrong. All right, 96. All right, subtract 64 on both sides. So you have 8x equals 32, and divide by 8 on both sides would give you x is equal to 4. And again, all we have to do is find x. So we are done with this example as well. On number 3, we have a tangent and a secant. So on this one, it was tangent squared is equal to outside times the whole thing. So this is your tangent, this is your outside, and this is the whole thing. So in other words, JK is equal to JL times JM, or JK squared, sorry. So that's 9 squared is equal to 6 times x plus 6. So now I have to distribute the 6 into this set of parentheses, which would give me 81 is equal to 6x plus 36. Subtract 36 from both sides. And you would have 45 is equal to 6x. And divide by 6. Seven 7.5. X is equal to 7.5. And our last example, number 4, tells us that AB is tangent to the circle. Find x and round to the nearest tenth. The hint says we'd have to use quadratic formula. So this is another example of tangent squared. So AB squared is equal to outside times the whole thing. So that would be AC times AD. So 10 squared is equal to x times x plus, or 2x, sorry, plus 4, because we're combining like terms. And there's 2 x's. So now I have to square 10 and distribute. So I would get 100 is equal to 2x squared plus 4x. And notice I don't have x squareds on both sides, so they won't cancel each other out this time. So what you're going to have to do is subtract 100 from both sides, which will give you 0 is equal to 2x squared plus 4x minus 100, which is a quadratic equation. And since it's a quadratic equation and not a linear equation, this is why we have to use the quadratic formula. For the quadratic formula, you need to understand your ABCs. So it's A is 2, B is 4, and C is negative 100. It's in alphabetical order according to the equation. And the quadratic formula is x equals the opposite b plus or minus the square root of b squared minus 4 times a times c all over 2a. So now let's substitute everything where it belongs. I'm going to put parentheses where I'm going to substitute. All right, so now I just need to insert the numbers. So B was 4, so everywhere B goes, put 4. A is 2, and C was negative 100. I know you can't really see it, it ran off the page, but there's negative 100 there. So now let's grab our calculator and type all of this in at once. If you're skeptical, type it in stages. But for time's sake, I'm going to type it all in at once. And this is how I would do it. Alpha y equals. So I would have negative, open parentheses, 4, close parentheses, and I would do plus first. You can't do the minus and the plus at the same time. And then get the square root of 4 squared minus 4 times 2 times negative 100, close parentheses. Drop down to the denominator, put 2 parentheses 2, and then hit enter. And you get roughly 6.14. And it said round to the tenths, so that's 6.1. Okay. And then hit second entry. And now the only thing we have to do is change the sign in front of the square root to a minus sign, and we don't have to retype everything. So hit minus now and enter again, and you get a negative number. So since x represents a distance, it's the distance between A and C, it can't be negative. So the only answer we're going to use is the positive answer. So 6.1 is the only answer we're going to use for this problem as our final answer. So x is approximately 6.1. And this concludes our notes for today.